Hi guys, welcome to my channel. This video is dedicated to solving example 4 in the Unit 6 Lesson 4 packet. So let's begin. A student prepared a 0.1 molar solution of formic acid, HCOOH, and found its pH to be 4.3 at 25 degrees Celsius. Calculate the Ka for formic acid at this temperature. So I'm going to start by underlining some important information, namely that I have a 0.1 molar solution of my acid and its pH is 4.3 at 25 degrees Celsius. Calculate the Ka, that's my ask, for formic acid at this temperature. So immediately you probably notice that this is a new type of problem. Usually we've been using Ka to calculate pH. Now we're going in the reverse direction. Don't worry though, the technique is the same. It's another rice table. So let's get started with that. So I'm going to start with my reaction. I have an acid, so I'm going to use an abbreviated dissociation reaction. Cool. All right, my initial concentration of formic acid is going to be 0.1 molar, while my initial concentration of H plus and COOH minus are going to be 0. Again, we can only shift right. So this is going to change by a factor of minus x, while these change by a factor of plus x. And my equilibrium is the sum of these columns. Okay. Well, now that I have these terms, the question is now what? Because typically I've been relating them through the Ka expression and the Ka value, which I've had, I don't have that anymore. Okay, so let's start by writing our Ka expression. Ka is equal to our concentration of H plus over our concentration of COOH minus all over our concentration of HCOOH. So I need to know what these things are equal to. I need to figure out what X is, and fortunately there's a way that I can do that. I'm given my pH, and pH is directly related to our concentration of H plus. Our equation for pH is, of course, pH is equal to the negative log of our concentration of H plus. In this case, I have my pH and I'm solving for my H plus, so I need to rearrange this equation so that the 10 raised to the negative pH gives us our concentration of H plus. So 10 to the negative 4.3 equals our concentration of H plus. And our concentration of H plus is equal to 5.01 times 10 to the negative 5. Cool, I have that. I'm going to put it in the solutions column in my rice table. 5.01 times 10 to the negative 5. This number is obviously very small. It is clearly going to have a negligible impact on this. So I'm going to assume that that's negligible. Yep. And because my H plus and my COOH minus concentrations both start at 0 and change by a factor of X, their equilibrium concentration is the same. So I have also solved for my concentration of my conjugate base. Awesome. Now I have everything I need. Obviously, these two have the same concentration, so I'm just going to square that. And that is equal to 2.51 times 10 to the negative 8th. Ka for formic acid at 25 degrees Celsius is equal to 2.51 times 10 to the negative 8th. See you guys next time.